Imagine you're trying to build an app that predicts whether a student will pass or fail an exam based on how many hours they studied. Your first instinct might be to use a straight line, like in linear regression, to predict the outcome. However, linear regression is designed to predict continuous numbers like a house price or a person's height. If you use it for pass or fail, the math gets messy. It might predict a value of 1.5 or minus 0.2, which doesn't make sense when the answer can only be a yes or a no. This is the specific problem that logistic regression was built to solve. The magic of the sigmoid function. To fix the straight line problem, logistic regression uses a bit of mathematical magic called the sigmoid function. Instead of a line that goes off into infinity, the sigmoid function looks like a stylish, stretched-out letter S. This function takes any value, whether it's a million or -5, and squishes it into a narrow range between 0 and 1. This is the game changer. By keeping everything between 0 and 1, the algorithm stops predicting abstract numbers and starts predicting probabilities. For example, it won't just say pass. It will say there is an 85% probability that the student passes. Making the final decision, once the algorithm gives us a probability, we need to make a final call. To do this, we use a classification threshold, which is usually set at 0.5. Think of this as a line in the sand. If the probability the algorithm calculates is 0.5 or higher, it classifies the result as a 1 pass. If it's lower than 0.5, it classifies it as a 0 fail. This boundary allows the model to take messy, real-world data and turn it into a clear, binary decision. The learning part of the process involves the computer adjusting the shape of that S-curve until it fits your historical data as accurately as possible. Real-world impact and conclusion. Logistic regression might sound simple, but it is the silent engine behind many of the technologies we use every day. It's the logic that decides if an incoming email is spam or inbox. It's used by banks to determine if a credit card transaction is fraudulent or legitimate, and by doctors to predict if a tumor is malignant or benign. While there are more complex algorithms out there, logistic regression remains a favorite because it's fast, efficient, and very easy for humans to interpret. It's the perfect starting point for anyone looking to understand how machines make decisions. In conclusion, logistic regression is one of the most essential tools in the machine learning toolkit because it bridges the gap between raw data and clear, binary decision-making. While its name sounds like it belongs to the world of continuous numbers, its true power lies in classification. By using the sigmoid function to map complex data points onto a probability scale between 0 and 1, it allows us to draw a clear line in the sand decision boundary to separate to true or false.